Good afternoon. Good afternoon. Welcome. Greetings. I'm Ed Bogish. I'm Executive Director of SyracuseCoE, New York State Center of Excellence in Environmental and Energy Systems. Many of you here, but others, this is your first time in the building. Welcome. This is our monthly Research and Technology Forum. We do it on the second Tuesday of every month, and invite you to come back. Next month's program is on June 11th, and it will feature presentations on indoor environmental quality by presenters from United Technologies Corporation, Eric Adams, from Carrier locally. Usha Satish is a faculty member at Upstate Medical University, and she's been involved in some pioneering work on understanding the impact of carbon dioxide on decision making. And now I'm blanking on the last person.
Larry Wetzel?
Larry Wetzel! How could I possibly forget Larry Wetzel? The founder and chairman of Air Innovations, one of our innovative companies in Central New York. But today, I'm very pleased to introduce today's R&T Forum on green infrastructure. You see the speakers there, and I'm pleased to introduce Matt Millay, who's going to moderate the program and introduce the speakers. Matt, as you know, is Deputy County Executive with responsibility for physical services, including stormwater management systems and green infrastructure. Before he joined County Executive Mahoney's administration, Matt was at the New York State Environmental Facilities Corporation, was executive vice president, and served for a while as acting president. And the New York State EFC is a leader actually nationally in implementing programs for communities across the state to address issues regarding investments in water infrastructure and green infrastructure. Matt is a graduate of Siena College, where he serves as an associate trustee. He has a master's degree in public administration from Columbia University. So from Columbia. It's great to have Matt in Central New York. He's here with lives with his wife Lori and his three sons, Ethan, Aaron, and Luke. Matt Millay.
Thank you. Thanks for the coffee, whoever got this forward. Always a pleasure to be at the Center of Excellence. Thank you everybody for coming this afternoon to hear from our esteemed and accomplished speakers. A la Chucky Holstein style, I won't read everybody's bios. We will make sure that everybody gets them though if you don't have them already. And I'll just talk very briefly about a little bit about our view on treatment wetlands and very, very brief introductions for our speakers. But as Ed mentioned, I work for the county and I've also worked at the state level, and I'm thrilled to see a discussion about treatment wetlands because we've, as you'll learn today, invested a lot of time, a lot of resource, a lot of energy into advancing the notion of treatment wetlands right here in this community, and it's happening elsewhere. There's a great project of similar natures in Louisville, in Sanitary District 1 in Kentucky, which was highlighted recently in a national publication about wastewater technologies. And it's interesting to see the discussion that was going on with that story. It was very similar to exactly what we're doing here, exactly what Matt Mark was going to talk about today. So we're very much on the cutting edge of a national movement. And what the county executive very much likes to talk about this wetland in the context of the Save the Rain program is A, we're not building a wetland. We're restoring an area that once was a wetland back to its original state as a wetland. And we made a huge mistake in the past when we thought it was a good idea, and it was largely for either expansion of urban footprints or mosquito control, or we're just using them as landfills, and we thought it was a good idea to fill in swamps. Now we know a lot better about the negative effects of filling in these natural treatment systems that nature created for us, and we're restoring one, which you'll hear about. And we're very proud of the fact that not only are we doing it aggressively here, Joni also likes to talk about the fact that you don't have to plug in wetlands. And that the concept of treatment wetlands in the long run will hopefully allow communities like ours to save money on energy and treatment costs for things that we could have built conventional treatment for. But otherwise, why not go back to these natural systems? I'll let our experts talk about it. Tara Doherty from CRA Associates. Tara and I have met just a few times, but we do a tremendous amount of work with Vern, Canastota Rovers Associates. They've worked for us on the Save the Rain program on phosphorus optimization studies at Metropolitan Wastewater Treatment Facility, which really, if you don't know, if you haven't been there, come to our Clean Water Fair and you can see the state-of-the-art phosphorus treatment system and ammonia removal system that we have there. Rich Martin, everybody's got to know Rich Martin here, right? Who doesn't know? I understand you just won a major award. And what do we got? It's on here somewhere, right? What'd you win?
SUNY Distinguished Professor.
Of course you are, right? His team have been working very closely with Matt and will be providing us with the scientific data that we need to justify to our regulators that wetland treatment technologies can work and that we shouldn't have to build more gray end-of-pipe solutions and spend more money on electricity and chemicals when these systems do work. And I'm also very proud to serve on the Onondaga County Resource Recovery Agency's Board of Directors with Rich. And we're
Except we don't agree on things, right?
Sure we do.
Well, we do most of the time.
Beat Covanta. That's what we agree on. Beat Covanta. And you know, a lot of great work from Okra. Rich has been on the board there a lot longer than I have, but I think we're both county executive appointees on that. And then Matthew Marco, our Vice President from CH2M Hill. CH2M Hill is our program manager for the Save the Rain program, and they're really leading the charge for us as we take the notion of balancing gray and green infrastructure in Onondaga County and using both solutions to help clean up Onondaga Lake and deal with our combined sewer overflow problems. What CH2M Hill has done is led our green team, designed our global solutions to how do we look at the city of Syracuse, think about green infrastructure, where's our opportunities to deploy green infrastructure, what type of green infrastructure should we use, where should we spend the resources that we have most efficiently and effectively. And we've come a long way from 2009 when they were brought on board to help the county executive win that fight in the courts. And I think you'll all be very impressed with what you see today on the tremendous amount of work that CH2M Hill has done on our behalf for this wetland in Harbor Brook. So with that, I'll turn it over to Tara. I think you're going to go first. Thank you for being here today.
Thank you, Center of Excellence, for inviting me to speak on treatment wetlands. I know that you're all here. Do I just press the button? I know you're all here to hear about the Harbor Brook project. I'm going to set the stage a little bit and give you a little bit of a background on treatment wetlands in general. And then the second two presentations will really hone in on the specifics of the Harbor Brook project. Okay. So this is just what I'm going to talk about. But, 15, 20 minutes here. Just give you a bit of an introduction to treatment wetlands. We'll look at some of the different kinds. Kind of talk a little bit about the energy considerations for these. As Matt mentioned, wetlands can use a lot less and potentially no energy as compared to other types of systems. And so I actually have a little bit of data on that I'll present. And then I'll just show you a few case studies. Our case study of focus today is definitely on Harbor Brook, but there's lots of applications of treatment wetlands, and I'll just show you a few examples. All right. So when you think of a wetland, maybe wouldn't be your first thought, a big basin with a bunch of plastic liner. And I don't know exactly with the Harbor Brook if they're using liner or clay, or maybe sometimes we use permeable bottoms. But often a treatment wetland is designed to be an individual system that has the water come in, it's treated, and only leaves and goes into the environment once it's been cleaned. There are examples where you'll see stormwater systems where the water can fluctuate in and out of the bottom, but a lot of wetlands that are used to treat highly contaminated water will kind of start out like this. It could be a plastic, it could be a clay liner, but something that doesn't let the water go into the surrounding environment. In terms of the general process of where a wetland fits in, a lot of the water that we're going to be treating is collected first, so that could be, if we're talking about groundwater, it could be pumped with a CSO, it's coming from the combined sewer system. Lots of different examples of how we get the water to this one often considered to be an end-of-pipe solution. So rather than a distributed system, we're collecting the water and putting it into the treatment system, and then it's discharged. That's just kind of our basic process of wastewater treatment. All right, so treatment wetlands are something that we hear a lot about. Seems like they're this great new technology, but really the original research on these started in Germany back in the 50s. And around the 70s it was transferred here, and New York State has some awesome history with really the beginning of treatment wetlands. So in Brookhaven, one of the first engineered constructed wetland systems was made in the United States. And then even closer to home here in Manoa, which maybe you've heard about this constructed wetland. It's interesting because it's local, but it's also interesting because it's one of the first that was able to start research on the horizontal subsurface flow. And that will have more relevance once I show the different kinds. So pretty cool. New York State, and particularly this geographic area, have great history with treatment wetlands. So how do people know how to design these? You know, from the 50s to today, there's been a lot of changes and a lot of research. Tons and tons of papers are always coming out about treatment wetlands and capabilities, whether it's removing BTEX or iron or whatever it is. There's all these great resources. So I kind of started here with what's on the left is kind of your most like general, basic. The EPA has guidelines on how to design wetlands, and they're pretty, I would say, I don't want to say generic, but not really specific. And then as we get into the New York State Stormwater Management Manual, there's some prescriptive criteria again on stormwater kinds of systems. And then there's the Water Environment Research Foundation is always producing publications. And they have a few really specific ones on landfill leachate treatment systems, as well as, I think they have one on like high ammonia removal systems as well. And then the textbook that came out about 4 years ago really takes all of the research, all of the published papers to that time, I shouldn't use the word all, many, because all is really a bit of a stretch. But that's really a great resource for finding out how different kind of contaminants are removed from wastewater. So that's kind of a little bit of the background of where people go to get information on how to design these. All right, so now the types. I realized when I looked at the presentation on the Harbor Brook, I may be missing one. And so these are your three kinds of, the traditional types of treatment wetlands. We have our free water surface, I'll describe what that is, a horizontal subsurface flow, and then a vertical flow. And what you see at the Harbor Brook, there's even a new creative type of wetland, these floating wetlands. And I'm not going to go into the details of those, but I'm going to say they're kind of mostly similar to the free water surface, although instead of the plants being rooted in soil, they're rooted in mats, and their roots are able to hang into the water. But they'll show you some more examples on that. So here's a little, I guess, schematic of a free water surface wetland. When you picture a wetland, this is probably what you picture. Water is coming in one side, you can see the water surface, it's going through emergent plants, you know, your typical cattails and those kinds of plants, and then coming out the other end, treated. And here's an example of they're called surface flow, free water surface. You can see water basically. This is an example of a park that was constructed around an open water wetland in Shanghai. Now the horizontal subsurface flow, this kind of system has been used a lot when we're treating contaminated wastewater. Maybe the system is in a community where the houses are closed and we don't want any exposed water. Just because you're treating wastewater doesn't mean the water can't be exposed, but sometimes we want to completely eliminate that concern. And so the water again flows the same manner on the schematic from the left to the right. But when the water comes in, I guess I do have a pointer here, but I'll just point here. It comes in and all flows below the surface. In colder climates like Syracuse or Minnesota, places like that, you can actually put just like a regular mulch you would find in a garden along the top, and that can insulate it and help with the biological activity that takes place in the wetland. That can also be kind of a very passive odor control system, and so this kind of system can potentially have no odors associated with it. And that's an example of that. You could literally just walk on top of this this wetland. Kind of not exactly what your picture's well, but another example. Vertical flow wetlands, they can look similar to the horizontal one that I just showed, but you can probably all guess what happens. Water comes in and it percolates through. Sometimes these wetlands can be filled with water, but often they're not saturated. The water is pumped or flows onto the top and then percolates down, and that's how it's treated. And here's an example of that. This is an example where it actually uses pumps, and each one of these little caps you see on the end is the end of a pipe that is all pressurized, and the water flows from the top down, so that we don't have any kind of preferential spots where more of the wetland is getting more water. So it's evenly distributed across the top. So now they're used for different things. You can think of the free water surface wetland. That really kind of encompasses a whole bunch of different kinds of removal processes. You can settle out kind of particulate material. These can remove phosphorus, especially when it's in a particulate form. We have aerobic and anaerobic processes that take place because we have exposed water and the oxygen transfer that occurs there, but then also deeper sediments can have anaerobic processes taking place. And then I have, so really in here we just have the wetland type, the dominant treatment processes, and then typical uses. So you often see this as a stormwater kind of wetland. Acid mine drainage, they're used for that often because acid mine drainage could have tons and tons of particulate metals. And we don't want a system that's made of a media and the water is flowing through to plug up and then have the water surface. Horizontal subsurface flow, these are typically used for domestic wastewater, sewage kind of applications. They can be used for some other things. They have a lot of anaerobic processes that takes place in them, unless they're mechanically aerated or something like that. And then the final one, vertical flow. Specifically, when these aren't filled with water, we can have the air naturally comes into the media, and these can enhance aerobic treatment processes like the removal of biochemical oxygen demand and also nitrification. And now each one of these processes, you can group them together and you can form a whole other system. So we could have a vertical flow wetland where we're nitrifying, followed by a horizontal subsurface where we might have denitrification, which is an anaerobic process. So lots of wetland systems merge a whole bunch of them together. And like the Harbor Brook, you'll see that they've put some in parallel or allow them to go into series, and you kind of can experiment with how to combine them to do even more. All right, some energy considerations and then just benefits, which probably all of you are aware of, but I'll just highlight a few additional things. All right, so now this idea that wetlands use very limited energy to remove contaminants in water. So what you see going on here is that we have our different kinds of wetlands or wetland type systems. So an aerated wetland where we're mechanically aerating it, the subsurface flow, the open water kind of wetlands. The more complex the wetland gets, generally aerated, that would require some kind of mechanical energy. That allows us to make the system smaller. Sometimes we want to use a system that generally uses less energy like a wetland, but that also is able to get us the removal efficiency we want in a certain area. So you can kind of play with adding a little bit of mechanical energy and kind of trading that for land. So you can kind of think of the energy-land trade-off is what can happen. Now this is actual data on different kinds of wastewater treatment plants, going from the most passive, a surface flow wetland, very passive system, all the way up to pretty complex mechanical systems that you might find like at the metro plant. And this is the energy utilization per volume of water treated. And you can see at the point where treatment wetlands kind of end here, and conventional treatment starts, the amount of energy that you need to treat the water is going up significantly. But again, it's traded off for land. So these systems on the right are going to be much smaller than the systems on the left. And that's kind of the trade between the mechanical and passive. So just some general benefits. This is a pretty cool wetland system, and I bet the Harbor Brook one is going to be pretty interesting and unique like this. This was a a combination of surface flow wetlands and I think vertical flow wetlands designed as a butterfly wing. So pretty interesting stuff you can do. This is a park. And just the idea of what we're doing here in Onondaga County is this idea of combining research and beneficial use and treatment systems. Some of the other things I have up here, educational opportunities, the research aspects, and reducing the life cycle energy is a huge aspect of these systems. When I was putting this presentation together, I did a quick search, and this is an article from the newspaper in Batavia. This isn't a headline you see too often. The Batavia wastewater treatment plant, one of the city's hidden treasures. Maybe there isn't that much going on in Batavia, but I guess a lot of birds are attracted. And the other picture that was in this article were all of these birders set up along the main road there with their cameras. So you can have this interesting aspect of treating water and providing a habitat at the same time. This is a pretty key, and I don't want to say one of the first open water wetlands, but this is one in Florida. And I forgot, they have a really cool website, and they have all of the different kind of bird species highlighted on their website. And there's always people there taking photos, some pretty cool things, and it's also in Florida. So.
It's jam-packed, and the name Cotahatchee is apparently Seminole, meaning constructed wetland.
Oh, nice.
That's one.
Yeah. And there's tons of examples like this. This was just 3 today.
Yeah.
All right, some just quick case studies. This is a project that I worked on. This was, I mean, the wetland part was interesting, but the building was absolutely amazing. They, if you can see this green roof up here, you can actually walk up onto it from the, not that that has anything to do with the wetland, but I thought it was pretty cool. Anyway, this was a wetland that they wanted integrated into the architecture, and so you can do some kind of interesting things. Nobody would really want a bubbling aerated tank of brown wastewater right next to the building. So this gives us some opportunities to do things that you wouldn't normally be able to do when you're using when you get to use a wetland. So this they're shooting a pretty low flow, about 1,500 gallons per day, just the water coming from this super efficient building. So they're using even less water than you normally would. It's just 2 wetlands in series, and then the water was going through disinfection, and then was going to be reused in the building. That's kind of a fun example. This is one of the earlier, so this is back in 1999 in Minnesota. The wetland, which I think in this picture was probably 5, 6, 7 years old, has kind of disappeared into the landscape. It's kind of a neat aspect. Some of these wetlands, especially the subsurface flow ones, can end up just kind of disappearing, especially almost looking more like a meadow. So this was treating wastewater from a community, I kind of forget how many homes, but about 22,000 gallons per day. There was a septic tank that was kind of the primary treatment. The water went into 2 horizontal subsurface flow wetlands and then was infiltrated into the groundwater. So those are kind of 2 domestic wastewater examples. Here's a little more of a remediation example. So this is in New York, treating about 250,000 gallons per day. This is contaminated groundwater that was pumped up through wells. And you can kind of see in this photo, if you can kind of guess where the water starts. It starts where the really, really red area is. And then, let me try the little laser pointer. So water enters here through some cascade aerators, which are basically corrugated pipe. So the water's aerated there. We settle out a bunch of iron, and you can kind of see the iron being removed through the system as it goes through. So what happens here, water comes in, it goes over and it splits between these 3 trains. And then after that, it goes over to what you might not even have seen, which is these other wetland cells for final polishing and pH buffering. So this could just kind of a different example of what wetlands can be used for. And this overall area, it says about 10 acres. We have probably a little bit less. And this construction, you see here, they're kind of similar. A lot of earthwork goes into constructing these systems. You can see that more in the Harbor project. Okay, that's that. So basically, just what I wanted to get across is there's a whole bunch of different kinds of wetlands that come in different sizes and shapes, and you can combine them in different ways to do different things. In general, they do have lower energy requirements, but there have been kind of advances made where we merge some mechanical processes with wetland systems. And I think one of the coolest parts about them is that we can accomplish these water treatment goals and also provide community amenities, and that would kind of lead us on into this community amenity project. So I don't know if we'll